All right, part 4, copper, plastic tube, and magnets. So we're going to pass a magnet through a plastic tube and through a copper tube. Here's Mr. Allen.
Hello. So this demonstration again is showing you that there is a relationship between magnetism and electricity. What I have in my hand are some rare earth magnets called neodymium magnets. They're getting more and more popular as the years go by. They are incredibly strong magnets. So here I've got an iron nail, and you can see it's like, it's really stuck. Like, I'm not faking. They really get stuck. And like to pull these apart, like I have to like slide them, like they really are. You can find these. They're fun to play with, but buy small ones, because if you buy the bigger ones, you can really pinch yourself with the bigger ones. So be careful with the neodymium magnets. So what I want you to see though is the relationship between magnetism and electricity. In order to demonstrate that, I'm going to bring my magnet first next to a plastic pipe. You know that magnets are not attracted to plastic, right? There's no magnetism going on there. And what I'm going to do, and you'll be able to see this through the plastic tube, I'm going to drop the magnet through the middle of the tube, and it falls just as you thought it would, right? Gravity was pulling it, and it goes right through the plastic tube. But we're going to contrast that to a copper pipe. Remember, we're picking copper for a very specific reason. What is the primary metal used in wiring in your home? It's copper. There are other metals that work, but copper works really well and is relatively cheap. So I've got a copper pipe. One thing you need to know, maybe you don't know this, is that, again, there is no relationship between copper and a magnet. There is no attraction between the two. There is a relationship, but there's no attraction. So it is not sticking. But this time, when I drop it, I'm going to drop it through the pipe, and let's see if you notice a difference. That seemed to take a little bit longer, Mr. Cosby.
Do that one more time, again, just so they, hold on, let me back up a little more.
You can hear it kind of rattling as it falls through, but it does seem like it's falling at a slower pace. Let's see if you can get a different angle where you're looking down the pipe so you can actually see the magnet as it is falling through the pipe. You ready, Mr. Cosby?
I'm ready.
1, 2, 3.
One more time from.
We'll do that one more time in case that didn't work out very well. You ready?
Yep.
1, 2, 3.
Whoa.
So you can see that there is a difference on how the magnet falls through the copper pipe versus falling through the clear plastic pipe. The science behind this is actually fairly complicated. What you need to know is that there is a relationship between magnetism and electricity. And a simplified explanation of what is happening is that when I bring a magnet near a piece of copper, if the magnet is moving, there are electrons on the copper that start to move. That's electricity. When electrons start to move, that is electricity. Well, we saw from the last demonstration, when I brought the wire and the battery near the compass, the electricity flowing through the wire caused the compass to move. So it appears, based on the 2 experiments we've done, that when you have electricity flowing through a wire, that produces a magnetic field. And now we have a magnet, a really strong one, that's falling, and we have a magnetic field that causes electrons to move in the copper pipe, which in turn, when you have moving electrons, electricity, that causes a magnetic field. So as I drop this magnet through, a magnetic field is being created inside the pipe that resists the fall of the magnet. So that's more complicated than what I explained. Bottom line, there is a relationship between magnetism and electricity. Magnets create electricity. Electricity flowing through a wire creates a magnetic field.
Good. All right, kids, answer the questions.